Welcome to video lecture on dynamics of machinery. So in today's lecture, we'll cover more numericals on Porter. Let us start with the next problem on this Porter governor. The arms of a Porter governor are each 250 mm long and pivoted on the governor axis. The mass of each ball is 5 kg and the central sleeve is 30 kg. The radius of rotation of the balls is 150 mm. When the sleeve begins to rise and reaches a value of 200 mm for maximum speed, determine the speed range of the governor if the friction at the sleeve is equivalent of 20 Newton of load at the sleeve. Determine how the speed range is modified. First of all, write down the given data. So in this case, mass of the fly ball is given 5 kg. Then mass for the central load on the sleeve is given 30 kg. The radius of the rotation of the balls is 150 mm when the sleeve begins to rise. So in this case, R1 equals to 150 mm is given, and R2 when reaches a value of 200 mm, means the value of R2 with us 200 mm. You have to find out the speed range. Determine first speed range and second modified speed range. When (20 Newton) of load at the sleeve. Means here you need to consider the friction. Considering friction. Okay. Now, first of all, draw the configuration diagram as per data available with us. So, corresponding to minimum radius of rotation and maximum radius of rotation, first of all, draw the configuration diagram. So length of both the arms with us 250 mm. The value of mass regarding the fly ball with us 5 kg and information regarding the central load with us 30 kg. Okay, now here the radius of rotation R1 with us 150 mm. Now give the corresponding names at various points, that is here the B with us, E with us, and here D with us. Okay, so this indicate h1, that is height of the governor corresponding to r1 radius. So this is about the minimum position. Now we'll draw the diagram by considering the maximum position. Here only change found regarding the radius of rotation, other things will remain as it is. So here the small m with us 5 kilogram, this one with us 30 kilogram, okay, then r2 with us 200 mm, then you need to find out this h2 length for this arm and this arm with us 250 mm, okay. Give the names at various spots. This indicates the maximum position. Now first of all, get the values of speed corresponding to this minimum position as well as maximum position. For that, if you concentrate on this triangle PBG, by using Pythagoras theorem, you can get the value for this one h1. Okay. Similarly, by considering the maximum position, you can get in similar way the value of h2. Okay. First of all, say why we need this one h1 and h2. If you see the formula in case of Porter governor, we know that formula. So what's about that formula? If you remember, n1 square equals to small m plus capital M by small m into 895 divided by h1. That's why it is very important to calculate the h1 as well as h2. Okay, let's start for the calculation of h1. So here we find the height h1. So height h1 is nothing but here this length PG. Okay, now from this triangle PBG we can get the value for this PG in this way by using Pythagoras theorem. h1 equals to PG equals to square root of PB square minus PG square. Now from geometry, just substitute the value for PB and BG. PB with us 250, square of this one. So here is that PB is here and BG is here. This one with us 150, this one with us 250. Okay. So substitute the value of BG here. Is 150. After doing calculation, we get the height h1 equals to 200 mm. The next step, convert this one into meter. Now we know h1 n1 square is nothing but small m plus capital M by small m into 895 divided by h1. So substitute the value of small m as 5, capital M as 30, divided by small m with us 5, multiply by 895 divided by h1. So already calculations for the h1 done by us in the previous step. So here is the h1 with us. Substitute h1 here as 0.2. Okay, then do the calculations and get the value for n1. After doing calculation, we found the value for n1 as 177 rpm. Similarly, calculate the value for h2. We know h2 is nothing but once again the same relation by changing the second configuration. Now h2 can be calculated from this relation. So h2 is nothing but, by using Pythagoras theorem, square root of bp square minus bg square. So bp square minus bg square, we can get the pg, that is h2. Okay, so substitute the value for bp as bp indicate the length of that link. So 250 with us, substitute here, bg with us 200 mm, just substitute here, do the calculation and get the value for h2 in terms of mm, convert this into meter like this. Now we know n2 square equals to small m plus capital M by small m multiplied by 895 divided by h2. Substitute all these unknown terms and get the value for n2. So here small m with us 5, capital M with us 30, then small m again with us 5 multiplied by 895 divided by h2 with us 0.15. So therefore n2, after simplification we get 204.4 rpm. So once calculation for n1 and n2 over, then get the speed range. So we know speed range of governor nothing but n2 minus n1. So this one with us 204.4 minus 177. So we can get the value for speed range in this way. I'll just mention that speed range or indicate the speed range by letter N. Now in the next step we have to find out the modified speed range by considering the friction, that is F is given here 20 Newton. Now by considering the friction, we know the relation N1 square equals to mg plus mg minus n, mg minus f divided by mg multiplied by 895 divided by h1. Now here important point is that when the sleeve moves downward, the frictional force F will act in upward direction, and corresponding to minimum speed, here the important point, when the sleeve moves in downward direction, just consider here, when the sleeve moves in downward direction like this, the frictional force acts in opposite direction. Here is the direction of movement of sleeve and here is the frictional force. When the frictional force is in upward direction, you have to consider that frictional force as negative, and in the reverse case, when the sleeve moves in upward direction, the frictional force acts in opposite direction of this. Okay, so here you need to consider that frictional force as positive. I hope this concept clear to you. Okay, so by considering that concept, just here the negative sign is considered. Okay, now substitute all the values. That is small m with us 5, then g with us 9.81 plus mg m with us 30 multiplied by here 9.81 minus frictional force with us 20 divided by m with us 5 multiplied by 9.81 multiplied by 895 divided by h1 with us, h1 already calculations for the h1 done by us, so 0.2 with us is substitute here. So after simplification we can get the value for this n1 square equals to 29500, and for n1 we get 172 rpm. Now we can get the relation when the sleeve moves in upward direction. Now for the reverse case, when sleeve moves upwards, the frictional force F is downwards, or that will act in downward direction. So this relation with us, n2 square equals to mg plus capital Mg plus F divided by mg multiplied by 895 divided by h2. Substitute all the values and do the calculation. Here you can get the value for n2 square equals to 44200, and corresponding to this n2 we can get 210 rpm. So we know the speed range of the governor, that is modified speed range, by considering the friction. You can get n2 minus n1 equals to 210 minus 172, we found that 38 rpm. So write here answer like this one without considering this one. We found the speed range equals to 27.4 rpm and modified speed range when we consider the friction into account can get 38 rpm. Let us start with the next problem. In an engine governor of the Porter type, the upper and lower arms are 200 mm and 250 mm respectively and pivoted on the axis of rotation. The mass of the central load is 15 kg. The mass of each ball is 2 kg and friction of the sleeve together with the resistance of the operating gear is equal to a load of 24 Newton at the sleeve if the limiting inclinations of the upper arms to the vertical are 30° and 40°. Find, taking friction into account, range of speed of the governor. First of all, write down the given data. So length for the upper arm with us, that is BP, equals to 200 mm. So length for the upper arm with us. Okay. Here, first of all, write down the given data. BP equals to 200 mm. Then length for the lower arm, that is BD with us 250 mm. Okay, convert this into meter. Then mass acting on that sleeve with us 15 kg. Then mass of the each ball is given 2 kg. Write it here. Frictional force with us 24 Newton. Here the inclination made by both the arms with the vertical axis are given 30° and 40° respectively. Let us consider here n1 is nothing but the minimum speed, n2 is nothing but the maximum speed. Okay, so first of all, develop the configuration diagram like this. Okay, by considering the length for this one as and this one is different one. Okay, so our ultimate aim is to find out the value for here n1, sorry, h1, h2 from this diagram, then get the values of n1, n2. Okay, then by considering the friction, get the difference. This problem is different than the earlier problem. Here the length for both the arms is given different. That's why the here inclination made by lower arm and upper arm is different one. So let us consider this one. First one, this diagram corresponding to minimum radius of rotation, and this diagram with us corresponding to maximum radius of rotation. Okay, so height of the governor, that is h1, can be calculated with the help of this relation, that is h1. Okay, just consider here h1. I can get this h1 by once again using this triangle. Okay, so first of all, get the value of this r1 by using this triangle PBG. Okay, so I can get the value for this one r1. So this angle with us, hypotenuse with us, so you can get easily the value for r1 as BP sine of 30. Okay, as this angle is given 30, just substitute here and get the value for this r1 as 0.1 meter. Then this h1 can be calculated by using the same triangle, that is BPG. Okay, so what's about this h1? H1 is nothing but here BP cos of 30. Okay, so we can get the value for h1 as 0.1732 meter. Okay, now get the value for here DG by considering this triangle BG and O. From this one we can get the DG equals to, by using Pythagoras theorem we can easily get that value, square root of BD square minus BG square. Just substitute the value for BD here, BG here, and get the value for DG. Okay, so in this case we can get the value for tan of beta 1, okay, in this way, then tan of alpha 1 in this way. So why we are doing the calculations for this tan of beta 1 and tan of alpha 1? So our aim is to get the value for here Q. So Q1 we can get in this way. It is the ratio of tan of beta 1 and tan of alpha 1. So after putting the value of tan of beta 1 and tan of alpha 1, we can get Q1 equals to 0.753. So what's about the use of this Q1? So in this problem, when the inclinations are given different one, then inclination made by both the arms is different, then you need to consider this one Q1. Now substitute the value for all the terms, that is mass, this one G, then capital M, Q1, etc. Okay, and simplify this one. After simplification we can get the value for this one, n1 square equals to 33596 and n1 equals to 183.3 rpm. Now corresponding to this maximum position, similar way get the value for r2, then get the value for tan of beta 1. So here the beta 2 with us. Okay, you have to find out the tan of beta 2 as well as tan of alpha 2 by considering this relation. So we can get the value for this one r2 as BP sine of 40. Okay, just focus on that triangles earlier we have discussed. Then get the value of r2 in this way, 0.1268 meter. Then height of the governor, that is h2 equals to pg equals to bp sine of 40. You can get the h2 equals to this one. Then get the value of the Pythagoras theorem once again. By considering the maximum position, you can get the value for this r2 by considering this triangle bpg. Okay, so what's about this r2? R2 you can get r2 in terms of bg is nothing but bp sine of 40, and similarly you can get the this one here, the dg with us. So from this triangle we can get the dg. Here the value for alpha 2 with us 40. Okay, so from that we can get the height h2. So height h2 with us, after doing calculation, 0.1532 meter. Similarly get the value for dg by substituting these values. Okay, you can get the dg. Now get the value for tan of beta and tan of alpha. Now look towards this maximum position diagram. Here tan of beta is nothing but, here the beta with us, beta 2. So tan of beta 2 is nothing but bg divided by this length, that is dg. Okay, and what's about this tan of alpha 2? Tan of alpha 2 is nothing but here alpha 2 direct with us 40 degree. From that you can get the value for tan of alpha 2 as well as tan of beta 2. So get the value for q2. Q2 is nothing but tan of beta 2 divided by tan of alpha 2. So substitute the value for tan of beta 2. Okay, already the calculation done by us in the earlier step. Tan of alpha 2 here and tan of beta 2 here 0.59, just substitute here and get the value for Q2. Now corresponding to the moment of the sleeve, when the sleeve moves in downward direction, the frictional force F acts in upward direction, and the minimum speed is given by this relation. So we know this relation, just substitute here, okay, in this way, and get the value for this one, N1, 183.3 RPM. So when the reverse case is happen, then we can get the value for N2 here, okay, in terms of this relation, okay. Substitute here the various terms, okay, in this way, and do the calculations for the same. So here Q2 value is substituted, then this one, okay, all the values are substituted here. So get the value for N2 equals to 222 RPM, and we know the speed range is nothing but N2 minus N1. So get the value for that speed range in this way, 38.7 RPM. Now the concepts regarding calculations of speed range by considering length for both the arms equal when lengths for both the arms are unequal, and by considering the friction values. I think this points clear to you. Thank you.